Alcohol, a molecular compound. The variety of observations and applications of the said substances in the prevention of COVID-19 transmission.
Molecular and structural formula of alcohol. Alcohols are among the most common organic compounds. They are used as sweeteners and in making perfumes, are valuable intermediates in the synthesis of other compounds, and are among the most abundantly produced organic chemicals in industry. Perhaps the two best known alcohols are ethanol and methanol, or methyl alcohol. Ethanol is used in toiletries, pharmaceuticals, and fuels, and it is used to sterilize hospital instruments. It is, moreover, the alcohol in alcoholic beverages. The anesthetic ether is also made from ethanol. Methanol is used as a solvent, as a raw material for the manufacture of formaldehyde and special resins, in special fuels, in antifreeze, and for cleaning metals.
Ethanol, also commonly referred to as ethyl alcohol, pure alcohol, grain alcohol, and drinking alcohol, is most common known as the alcohol present in alcoholic beverages. Ethanol, which can also be abbreviated as ETOH, is a colorless liquid with a slight odor and is soluble in water. It is flammable and volatile, so it evaporates easily when left in an open container. Ethanol's chemical or molecular formula is C2H6O. This chemical formula can also be written as CH3CH2OH or C2H5OH. It is made of 9 atoms that include 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. However, the structural formula of ethanol, C2H5OH, provides a little more detail and indicates that there is hydroxyl group at the end of the 2 carbon chain.
Its chemical structure is illustrated in the following picture. Here, there is a methyl group, which is the CH3, a methylene group, which is the CH2, and a hydroxyl group, which is the OH, in the chemical structure.
Examples and illustrations of the ethanol structure and chemical formula. 2 common ways to represent the structure of ethanol are shown. On the left is the atomic stick representation of the structural formula, and on the right is the ball and stick model. The alcohol in alcoholic beverages is ethanol. Ethanol is a 2-carbon alcohol with a terminal hydroxyl group.
Physical properties of alcohol. Discussing the boiling point of alcohols, solubility of alcohols, and the acidity of alcohols. The boiling point of alcohols. Alcohols generally have higher boiling points in comparison to other hydrocarbons having equal molecular masses. This is due to the presence of intermolecular hydrogen bonding between hydroxyl group of alcohol molecules. In general, the boiling point of alcohols increases with an increase in the number of carbon atoms in the aliphatic carbon chain. On the other hand, the boiling point decreases with an increase in branching in aliphatic carbon chains. The van der Waals forces decreases with a decrease in surface area. Thus, primary alcohols have a higher boiling point. 2. Boiling points of alcohols. The solubility of alcohol in water is governed by the hydroxyl group present. The hydroxyl group in alcohol is involved in the formation of intermolecular hydrogen bonding. Thus, hydrogen bonds are formed between water and alcohol molecules, which make alcohol soluble in water. However, the alkyl group attached to the hydroxyl group is hydrophobic in nature. Thus, the solubility of alcohol decreases with the increase in the size of the alkyl group.
Physical properties of alcohol. Number 3. The acidity of alcohols. Alcohols react with active metals such as sodium, potassium, and etc. to form the corresponding alkoxide. These reactions of alcohols indicate their acidic nature. The acidic nature of alcohol is due to the polarity of the OH bond. The acidity of alcohols decreases when an electron-donating group is attached to the hydroxyl group as it increases the electron density on the oxygen atom. Thus, primary alcohols are generally more acidic than secondary and tertiary alcohols. Due to the presence of unshared electrons on the oxygen atom, alcohols act as bronze bases too. Chemical properties of alcohols. Alcohols exhibit a wide range of spontaneous chemical reactions due to the cleavage of the CO bond and OH bond. Some prominent chemical reactions of alcohols are: number 1. Oxidation of alcohol. Alcohols undergo oxidation in the presence of an oxidizing agent to produce aldehydes and ketones, which upon further oxidation give carboxylic acids. Number 2. Dehydration of alcohol. Upon treatment with protic acids, alcohols undergo dehydration, or removal of a molecule of water to form alkenes.
Facing the COVID-19 new coronavirus disease pandemic, the countries of the world must take decisive action to stop the spread of the virus. In these critical circumstances, it is essential that everyone is informed about other health risks and hazards so that they can stay safe and healthy. Applications for the prevention of COVID-19 transmission. Alcohol is effective against influenza virus. Ethyl alcohol that is 70% is a powerful broad-spectrum germicide and is considered generally superior to isopropyl alcohol. Alcohol is often used to disinfect small surfaces and occasionally external surfaces of equipment. Rubbing or isopropyl alcohol is a common and surprisingly versatile household item. It has been reported that rubbing alcohol that is 70% is effective for disinfecting skin such as hands. However, it is said that there is no effect unless it exceeds 70%. Now, let's dive to this Q&A. Due to the effects of the COVID-19, there are no disinfectant and disinfection ethanol. What should I do? The disinfection ethanol can be handmade. How to make a disinfection ethanol? Handmade disinfection ethanol can be made with absolute ethanol and purified water. Protect yourself from the coronavirus. Use rubbing alcohol to disinfect your hands, your belongings, and your surroundings.